Welcome dear students. Let me introduce an important method for synthesis of carbohydrates. The Kiliani-Fischer synthesis, named for German chemists Heinrich Kiliani and Emil Fischer, is a method for synthesizing monosaccharides. It proceeds via synthesis and hydrolysis of a cyanohydrin, followed by reduction of the intermediate acid to the aldehyde, thus elongating the carbon chain of an aldose by one carbon atom while preserving stereochemistry on all the previously present chiral carbons. The new chiral carbon is produced with both stereochemistries, so the product of a Kiliani-Fischer synthesis is a mixture of two diastereomeric sugars, called epimers. For example, D-arabinose is converted to a mixture of D-glucose and D-mannose. The Kiliani-Fischer synthesis proceeds through cyanohydrin and aldonic acid lactone intermediates. The first step is to react the starting sugar with hydrogen cyanide or aqueous sodium cyanide. The cyanide undergoes nucleophilic addition to the carbonyl group of the aldoses to give the cyanohydrin. The cyanohydrin is heated in water, which hydrolyzes the cyanide into a carboxylic acid group that quickly reacts with itself to form a more stable lactone. Now there are two diastereomeric lactones in the reaction mixture. They are separated by any of the numerous separation methods, and then the desired lactone is reduced with sodium amalgam to give corresponding aldose. If we start with D-arabinose, the D-arabinose is converted to a mixture of D-glucononitrile and D-mannonitrile, which is then converted to D-gluconolactone and D-mannonolactone, separated and reduced to D-glucose or D-mannose. In practice, the Kiliani-Fischer synthesis is usually used for production of sugars that are difficult or impossible to obtain from natural sources. While it does provide access to every possible stereoisomer of any desired aldose, the process is limited in by its low yield and use of toxic reagents.